Hello, everyone. Welcome back to the subscriber feed. So this is going to be a new feature or a new kind of bonus, extra bonus or something like that. But basically, I'm just going to walk through some of my setups, and hopefully you guys find this helpful. I don't know if it's a little bit more useful than just getting dumped like a scene file. So usually someone explaining their thought process or how they decided to work a certain way, or which part was more challenging than other parts. It's always been really helpful for me, so I'm going to try to pass on that knowledge to you guys. So this is the final result of this file we're going to be looking at today. And it took me a little while to prepare, so we're doing basically KineFX. I have some other videos here. This is rigging geometry, where each flower petal has its own skeleton. So this is the base kind of animation. And what happens with this is it gets fed into a Vellum simulation. So it's attached to the geometry or guided by the geometry to get a more natural wind kind of looking motion. Just add some extra, more natural kind of effect to that so it doesn't look as robotic. And lastly, there's like some Vex kind of deformers and stuff like that I was doing. And then just looking at the UVs, we add a little bit of detail in the shader, just with the displacement mapping and some stuff like that. So we'll get started, dive in here. You guys should see this similar layout and everything like that, and I've tried to link up all the files, like texture files and stuff like that, so you shouldn't be missing anything. So just at the very, very top here, we're just starting with a line. We're basically using this to build a profile of the flower petal. So just looking at this curve right here, or this ramp, this is literally just what is getting driven by the X, the horizontal deformation of the line. And this one here, we're just basically starting with way too many points than we need, and then defining the actual like segment length or resolution of the line that we want. And polypath, sometimes this will just clean up curves or reorders vertices, or it can just, it's kind of like a useful way to kind of like make sure your curves are clean. It can fix a lot of things. If you look inside of it, you can see what's going on or whatever. But yeah, this is very similar workflow if you've ever made vases or vases or things like that. You probably start with a profile like this as well. You revolve the curve around 360 degrees or whatever. You make a dreidel or a vase or any kind of like drinking instrument or anything like that. But in this case, all that we do is slide the curve from one side to the other. So just over here, -1. And then divisions, this is going to be your internal like divisions to make up the petal. So just a, kind of like a two-dimensional revolve, or just mirroring everything in 2 dimensions. And then blurring stuff to keep like a smooth profile. And then this match size is nice. It will just return us or try to get us close to the original size. So as you blur, you kind of lose some volume. This just pops it back to the original size. And then here, this is just recording UV textures or coordinates. If you just look at the quick shade here, this is just going to project planar projection along the z-axis here to start with UV coordinates. And then these are useful for even if you run like deformers or stuff like that. If you work with UV space, so if we take a look here, we'll just put color from the UV. I'm going to have to switch this to vertices. So if we look here at the different channels, white, we have a nice gradient that goes from the bottom of the petal to the top. And with the red channel or the U channel, this just goes from left to right. So these are really useful attributes, or it's almost like a rest position. So if you want to assign or kind of bend the top of the petal more than others, you can influence different areas of the petal using this attribute. So it's not only useful for textures, but also for driving deformations or things like that later on. Here I just am rotating everything 90 degrees. So we're eventually going to build out a skeleton. And that's going to be driving the deformation of this petal. So I just wanted to get it lined up on the same axis as the skeleton. And then just using the bend here, you can get some kind of basic petal curvature or something like that. This is just the rest position. We don't need to worry too much about it, but I found that having like a little bit of bend instead of being completely flat helps me out. And then just converting this to a polysoup. This can be useful. If you represent each petal as one primitive, it can be helpful to work with things that way. And then what's happening down here, I decided to work with some textures that were different later on. So if I just press the 5 button here, you can see in my UV layout, what I was doing up here was our starting position, just the default planar projection. I wanted to use this texture here with some nice veins and detail and stuff like that in it. So I was just hand editing things to realign it with that texture, the way that it's laid out. And then at the end here, I'm just copying that UV layout into another attribute. So what that lets us do, if we look down here, we still have the original UV coordinates. If we just look at our spreadsheet, we still have our UV coordinates, and then we also have UV2. So we have an alternate set of texture coordinates. So we can use either of these or both of these depending on your mapping. If you want to do like noise in the shader, it might be better to use this straightened layout. And then if you want to read from this actual texture map, then it's probably better to use the skewed one. This is a little tricky, but just helped me out shading everything. And then in this other chain, I'm just going to press the 1 key to get back into the perspective world space. Again, just starting from lines. These are kind of be like arms or legs if you think of traditional skeletons. And if we look over here, we're eventually going to get to something like this. So we just have kind of this main spine, and then these arms that kind of branch off that can be used to bend stuff inwards or outwards. So we have, let's take a look down here. This one, these, and these. So when we merge them all together, we have the main spine. It's like the backbone. And then we have one side of arms and another side of arms. And right now, these are all just base curves. I made some groups to keep track of the left side, the right side, the spine, and the tip. But other than that, there isn't too much special. One thing I did do is run this orientation along curve to define the transform. So like usually you've probably seen people use this maybe to assign normals. You can get other axes or stuff like this with it, but you can also record this whole matrix that's the transform of the curve. So if we look, visualizing this rig, this visualize rig is a really useful node. It's a little hard to see with the way they laid things out. But if we go up to this transform here, if I change this roll, you can see I'm actually changing like the orientation of these joints. So if you're going to be rotating things in like joint space or based off of this axis, like local space later on, you definitely want to have a lot of control over the way that these are laid out. So I spent some time with these different transforms and stuff like that, making sure that the y-axis was always up. This x-axis, or the red one, was always pointing like towards the back. And then the z-axis was always pointing outwards from the center. So hopefully that makes sense. And the rig doctor here, this just initializes your skeleton for you. So if you look at the spreadsheet, you should get these local transforms and like all the kind of KineFX friendly attributes and all that kind of business will get calculated automatically for you. So it just adds them all. And then this guy, of course, just a quick way to visualize it. And it just kind of works as like a visualizer if you've used this one before, just to see like guides in the viewport. But as soon as we keep going down the chain, then you don't see those little like gnomons or guides or whatever later on. So that gets us down to here. So we have basically our petal, single petal geometry, and then the rig or the skeleton that will match up with it, and then it will be used to deform or to drive any animation of those petals. Okay, so we'll keep moving, and what I'm actually going to do is start with this little example that I've put aside over here. Sometimes I use these object merge kind of like fetches or just links. If you go up here and do view, show for selected nodes, like if you hover or select them, you can see which geometry it's fetching. So this is, I don't know, just to keep like a clean network or without getting too many lines crisscrossing, I'll use these just to make little breaks in my network. So what's happening over here, we have the petal, we have the skeleton, and we capture the bones in this rest position. This adds a lot of like internal attributes here. That's basically the captured state. Like if you were familiar with weight painting or doing stuff like that with rigging, it's basically saying which part of the geo should get driven by which part of the skeleton. So then if you move or change the skeleton at all, it can bind that or it can apply that animation to everything. So what I was doing over here was using these rig poses, and basically depending on the root group, which is just 0.0, it's going to be the starting point down here. Working on the spine, so you can see, because we're transforming a rig, we can make curling motion or poses or stuff like that really easily. This is one big advantage to KineFX, is that you get that kind of like cumulative transforms. So the same thing with the arms. You can just bend things, distort them or whatever pretty easily and pretty quickly. So I'm just basically hand sculpting or hand posing two different states here. We have the skeleton blend that can pretty nicely like interpolate between those two. So we have I'm calling this one like the rosebud or the bud position. And then this one on the right side, this is the blossomed or the fully bloomed position. And the skeleton blend works a lot better than just like a blend shape, because we have bones representing everything. So like all of the spherical linear interpolation and all of the transforms are like treated a lot better than just looking at two different vertex positions and interpolating between that. So if we look at the result, we get really nice arcs in our rotation and in the motion of everything. And what I was saying over here is it's just useful to work this way if you're going to test simulations on just a single petal. It'll go a lot faster than doing the whole thing. But over here we'll move along now, and what we're going to end up doing, we could go over here quickly. What we're going to end up building is basically an entire skeleton for the flower. So just taking that one single skeleton, transforming it around, and assigning some attributes so that per per petal, we can determine the blend. So if we look here, this is actually driven by a primitive attribute. So each skeleton or each connected petal that has an attribute on it that tells this blend how much to interpolate or switch between the bud position or this closed position, or to fully blossom everything. I had some stuff down here I was doing just to make some breakdowns or whatever, but I thought you guys might find it somewhat useful. This is just like my own visualization of the joints. I don't know. I thought it looked a little bit better than this one with these like big. I don't know why they put the big spheres over everything, and it's a little bit hard to see. So just for presentation purposes or whatever, I was using these hand picked ones. So yeah, just taking the whole flower now and creating a skeleton or a bunch of skeletons to represent each petal, which animates for the base animation. So again, like we were doing earlier, we just hand sculpt the two poses of the skeleton, and this one's copying and transforming the bud position, like the rosebud. I also added some scale just to that. So another good thing with joints, you don't have to use rig pose. You can even just transform them using the regular transform stop if you want. You can even do like bend or any of this stuff, and it will still update all of the transformations as well, which is pretty cool. So yeah, that's it. And this is one kind of gotcha, is that after you copy all of the skeletons, they'll have names which clash with each other. So if we look at the spreadsheet here, you can see each joint, it's like 0.0 through whatever, and then it keeps repeating. So if you're doing blending or anything like that, it's going to complain if it finds more than one joint on your skeletons. Like it won't know which one to pick. So this is just a quick way to basically make them all unique. So we're just naming them after the point number. So afterwards, you just get these that increment forever, and they never overlap or clash with each other. And doing the same thing over here, but with this copy method, I wanted to do it a little bit more custom to get more control over everything. So what I actually ended up doing was creating a point for each petal that's going to get copied to it. And then each of these points has a translate, which is just the position, but it also has this transform matrix attribute. So if you work with this one, you're basically only able to define this global amount, which just keeps getting like concatenated or added on to the previous copies transform. So it just stacks kind of like that. But if you want to have complete control over each resulting transform, this is kind of like a really useful way to do that. So we can look down here. You can do like this scale ramp. This will let you set bigger or smaller petals. What I wanted to do down here was like shrink the ones inside. So using this ramp, like you'd never be able to have that level of control if you're just using this typical copy and transform. So this is one of the reasons why to build it out like this. Another thing here, if you look over here, we're rotating each leaf 140 degrees, like around the circle. I'm doing the same thing over here, 140 degrees. We just have to convert it into radians for this function. But I can also add this jitter, or this kind of like random. So each petal, we could see without it, it might look a little too uniform. But if you just want a little bit of randomness for each copy, this is kind of nitpicky or really getting down to specifics or whatever. It's useful to have that level of control. And then the other thing I'm doing is rotating some of these outwards. This is a little too much, but I'm just going to increase it. So we can bend certain petals inwards, certain ones outwards. You just have a lot more control working with this way, because you can basically change the transform per copy. Here you can only define a global transform, which keeps kind of stacking on itself. So that's all that happens here. And then with this vex code, this is defining the grow, the primitive attribute, that's basically going to change from 0 to 1, depending on if we want these to get blended between the bloom pose or the bud pose. So if you look over here, based off of that primitive attribute grow, that's all that determines how much this blend should alternate between one or the other input. So the same thing's happening over here. We just need this grow attribute. It's pretty simple remapping of just the frame number, the copy number, to adjust it. You look at the spreadsheet, or you would visualize it in other ways. Could do like this color node. And if we set it to ramp from attribute grow, need this to be primitive, we'll just make it infrared. So over time, these are growing. It doesn't make as much sense because we're looking at this already in the unfolded position. If you plug it in over here, this might make more sense. So basically, starting from the outermost petals, working its way to the innermost, that's when we like trigger the growth. And then this subnet here, this is a little hacky. This is basically doing everything I could to avoid using a chop network. Basically, all of these lines right here, it's graphing the grow attribute. And what I did was just blur it to get like really smooth interpolation. So each line here is a graph of each petal's grow attribute from 0 to 1. And I was getting this weird like kink at the top of it. So just being able to use SOPs or whatever to blur that or to smooth that, and resampling things. Pretty simple way, but kind of hacky way to basically create a actual SOP geometry curve representing the animation curve, or that this is just the attribute's value over time. And then just copying it back over here to update it. So if we look at what's going on here, we have the same petal geometry. It's at its rest position. And then using this for loop, basically for each primitive, or for each unique copy number, it's going to grab a petal from rest position, grab the rest skeleton to do the deformation, and then it will find like the current petal to deform it with. So you do it if you just want like the single pass to view a single petal at a time. So it's just going to go through all of them and assign a petal. I guess I have to view it from down there. But each skeleton that we're blending between up here, it's going to take a petal and a rest skeleton, capture it, deform it to the petal in its like grown state, and bind the geo with it. So basically, if we look at this for loop is pretty simple. This is doing the same process inside of it, but also at the end, it's deforming the actual geo, and then it's copying the attributes that we want to use, like the growth attribute, that goes from 0 to 1. That's going to be really useful later on if we want to, again, just visualize it. Take a look here. And go back to infrared. Boom. So this can be really useful in the simulation if you want to drive like stiffness or wind or all kinds of properties. You can use this attribute to determine like even a deformer if you want to just add some little noise. If you wanted to change the shader's like displacement amount or anything like that, it's super helpful to have that attribute with you. We don't need to worry too much about these penetrations. What I ended up doing was there's a little bit of things that I did here to up-res and kind of like add some deformation here that would add some detail. But the Vellum simulation itself will fix those penetrations for us. So if we look like right here, you can see this is kind of hard with this texture because it's like clashing or whatever. But the Vellum simulation, it does a pretty good job. I guess there's a little bit of stuff poking through, but it does a pretty good job of like keeping this stuff. This is just guide or template geometry that it's going to follow. So you could look at the result compared with that, and you can see it bends things internally to keep that stuff from going too wild. So we can get into the Vellum simulation now. The way that I set this up, another thing you can do as well if you want to simulate or solve things quicker. If you just do a blast node or set up your process, I can do 0 and delete non-selected. This is a quick way just to extract a single petal. So I'll just temporarily have that in my chain if I want to work more quickly. So we're basically doing the same thing to all the petals, but if you want to test or iterate on a single piece of geometry, it'll be a lot faster. So I'm just randomizing the primitive numbers here. So instead of kind of a regular incremental scheme, they all get completely randomized. Because then when I group them, I can group randomly 1 out of every 38 faces. So instead, without that, we kind of get like a little bit of a regular repeating pattern. If you use lower numbers, it's a lot more apparent, like you get a checkerboard effect or whatever. So if you just want to grab purely random primitives, just the sort sup, and you can even use this to get different seeds and stuff like that. But the idea here is we're basically just constraining a subset of the primitives to the animation. So instead of everything being like, if you're imagining a marionette or something like that, just attaching strings or guides or whatever to certain primitives, it's going to look more organic than constraining everything. Then this is the typical cloth constraint, just initializing the cloth, pretty simple. This one is the more advanced one that's this attached to geometry. So this one's kind of secret. It's kind of hidden, but basically if you use this third input, usually it's for collision geometry, but in this case, this is the geometry that you want to attach it to. So it's itself. And I'm using that group that's the attached group that we made up here. So we're only attaching that many primitives or a subset of primitives to it. So we should be able to go through the solve pretty quick. So again, just working on a single petal, it doesn't take as long. And you can see, you can even work sometimes like the template flag there. That's a good way to check how closely you're getting to the guide geometry. So if we maybe switch this group around, and I'm going to get like 1 out of every 2 primitives. Originally, we were doing 1 out of every 32. So in this case, just doing 1 out of every 2 primitives, you can see we're not getting as much detail or like wrinkling or anything like that, and it's really closely matching our guide. So you can play around with how much you want to match your guide geometry. For certain materials or things like that, you might want even less than that, but this one I just found was a pretty good balance of like, you're basically mixing like rigidity or how much you want it to conform to the original simulation, and then how much natural kind of flutter you want. So it's super useful to work this way because you have that level of control over everything. We could quickly go inside here. So we use this to update the stretch constraints. Basically, anytime you have a simulation where the edge lengths of the geometry is changing, like these faces are getting bigger, so their edges are going to get longer. If you don't specifically tell Vellum that you're changing the length of those constraints, it's going to try to always keep them really small. So I'm just going to jump inside of here. If I bypass this, we disable that update, and we can try the simulation, but you can see it's basically never going to let the edges get longer than that. So if you're not updating the constraints or the stretch constraints, it's going to keep trying to stretch it to be like its original size. So that's kind of one gotcha, or one important thing to get in there. And then I'm just pulling in the current value, or because we're updating that grow attribute. So I'm pulling it in every frame of the simulation to update it. Otherwise, it would just be stuck on the initial first frame value that it gets initialized as. And the reason to do that is so I can drive my wind forces here based off of that, how much the pedal is growing. So at the start, when it's in this position, we don't want it blowing around because it should be more stiff. And I'm also doing here, like, I'm changing the offset numbers here based off of the pedal index. So we can run a unique noise pattern on each pedal. And then this one is just more of a global or uniform noise that gets applied to everything. So that's it for the Vellum portion of things. Pretty straightforward. At the end of the simulation, just a good idea to remove extra attributes. If you look here, the like Vellum solver has a bunch of attributes it uses internally. It's like 30 or something, so like uses more memory. If we look here, this is like 1.21 megabytes, and then this is like not even half a megabyte. So anytime you're saving a long sequence of geometry or a lot of portions of things, like any little things you can do like that to clean things up definitely helps. Okay, so we're in the final stretch now. We're just wrapping things up, looking at the post-sim enhancements and things like that before rendering. So this right here, we're just copying over the grow and index attributes from the animation geometry. So the point count doesn't change or anything like that. So even though we cleared off a lot of these extra unnecessary attributes, we can grab back anything that we want post like reading it from disk. It's a little bit slower than saving it to your hard drive, but it does save space. So it just depends. It's up to you how you want to work. And then these nodes right here, this is really helpful way to just blur or smooth the petals closest to the bud state. So basically, based off the petal index, to grab the ones, basically the index numbers over here are going to be lower, or I'm sorry, they're going to be higher because we start like 0, 1, 2, 3, 4, 5, 6, 7, 8 until we end the spiral in the middle. So the higher index numbers we're going to want to blur those more than others. So we just make this blur weight. This is going to drive the blur, and then we don't need that attribute anymore, so we can clean it up. So selectively blurring certain petals is pretty useful. I'm going to recalculate the normals. Down here, I'm doing a bunch of deformations based off of each geometry or each petal's normal direction. So I want to make sure that that normal is accurate. So just recalculate it. So adding some wrinkling, and that's based off of, we're running unique noises per index, and we're also running or generating the noise based off of the UV or the texture coordinates, and then also incorporating the growth. So the outermost petals will be distorted or wrinkled a little bit more than others. I was just layering a couple of these to really kind of dial in the look that I wanted. Can also do things like based off of that UV horizontal or vertical position, we can bend just the tips of the petals, which is pretty cool. Can do that, just repeat, kind of like iterative or multi-segment kind of curling. If you did it enough times, you might end up with like kind of stuff rolling on itself or whatever. I think this one here is just like super subtle. And lastly, this was just a blur kind of uniformly over everything just to relax. Or I found out that it looks pretty cool in the viewport, but it's like to render it, it's a little gnarly. So just to smooth things out a little bit better, blur everything, can subdivide to really get like super high resolution. And this is going to be a final layer of wrinkling just for the edges. So I wanted stuff that still looked really smooth, but also had like fine detail. So that's why I ended up subdividing, like blurring, subdividing, and then a final layer of wrinkle. So like comparing it with this, turn off wireframe, this looks somewhat gnarly. Down here it just looks a little bit more like fluffy, both like silky, but also detailed, which I found like matched references or whatever a lot better. And that's pretty much it. So can look at like a rose color texture map just based off of the standard UVs, like that original just projected along the z-axis. But down here you can see if I switch to the UV layer 2, like that's where I rotated everything. So with this rose texture here, this is just a standard like laid out like a grid or whatever. It's just laid out straight. But the texture map I wanted to use had that rotation to it. So this is why I can switch to the alternate texture coordinates, and then I can use that and it will line up a lot better. So in the shader for Redshift, we were able to do some, not only use this as a color map, but also to drive deformations or like displacements. So get really subtle, really nice, super detailed, super sharp fluffiness out of those textures, which is pretty cool. One thing you need to make sure, don't make this mistake. If you put this in here and then you try to render it with Redshift, it will mess you up because this assigns a shop material to your geometry, which overrides your Redshift shader. So that's one of the reasons I had that alongside there, or this one underneath my render flag. So be careful with these UV quick shades. They're really useful for working in the viewport, but they can throw you off at render time or whatever. So that's it for the SOP workflow. The Redshift shader is pretty straightforward. Basically take this texture map. I did do a little gamma correction on the file read. And then I'm also just doing some remapping. This is kind of like the levels tool in Photoshop. And then this is another operation similar to a gamma. That's just adjusting like the curve or the fall off of your luminance. That's pretty straightforward shader. I am using the two-sided or the backlighting like translucency. So I found that that was giving me this very like tissue paper, delicate type of result that lets a lot of light kind of bounce around inside of here. Without that, I was getting like more crunchy, contrasty renders. I really wanted like this soft, glowy, kind of like delicate stuff that looks pretty good. So it's a pretty straightforward shader. I was trying some subsurface scattering. I also did try like extruding these petals at one point to give them thickness, some other stuff like that, but I found that this worked out the best. And then this is just the displacement down here. So could take a look, could even do we'll try this out, see if it works. Redshift viewport IPR. It might be a little bit wonky because you're running a displacement shader, so every time if you move the view around or whatever, it will probably have to update, rebuild or redice the displacements, but it could be cool to see if it works here. It's a new feature they added in Redshift like a couple minor version updates ago, a couple months ago. So it just lets you run the render right in the viewport, which is a little bit nice. It's super cool to be able to do that without having to change your render pane and stuff like that around. But I have a feeling like as soon as I zoom in here, it's going to try to redice displacements or whatever. But it seems to be pretty responsive, which is pretty cool. So yeah, lighting your scene and just adjusting things or whatever, the viewport IPR is a cool way to work. Super interactive and can work really quickly. If any of you use Mantra or remember the good old days of CPU ray tracers, you would never be able to work this quickly. So yeah, that's it for this example. Hope you found it helpful. Hope it wasn't too long. I tried to add a good amount of comments and sticky notes and stuff like that as well that should help you out offline or whatever. But yeah, let me know if you find these breakdowns or these little like walkthrough POV explanations helpful. I could keep doing them.